Hello and welcome to Precalculus lesson number 7. In this video, we're going to learn about inequalities. We'll start by looking at properties of inequalities and see which properties are similar to and which properties are different from the properties for equality. As far as the addition and subtraction properties of inequality are concerned, they're very much in line with what we learned about those properties for equalities. If you have an inequality like A less than B, then you can go ahead and add the same quantity to both sides, and that will preserve the direction of the inequality. And the same goes for subtraction. If you have an inequality like A less than B, you can go ahead and subtract the same amount from both sides and preserve the direction of the inequality. When it comes to multiplication and division properties of inequality, this is where things take a little bit of a diversion from those properties for equality, but only if you're multiplying or dividing by a negative number. So as long as you have an inequality like A less than B, and you go ahead and multiply by a number C, which is greater than 0 on both sides, you preserve the direction of inequality. And the same goes for division. So it works for both multiplication and division. But if you multiply both sides of an inequality by a negative number, then you have to change the direction of the inequality. So this is the one thing you have to be really careful about when you deal with inequalities. Anytime you multiply both sides of an inequality by a negative number, make sure that you switch the direction of the inequality immediately. And of course, you can see why that is true very easily. It has to do with the way the number line works out. So for example, if I have this picture here, see? Now we know, for example, that 2 is less than 3, right? But what happens when we multiply both sides by -1? See? On this side, it's -2 that's greater than -3. So even though 2 is less than 3, -2 is going to be greater than -3. So this is why this switch needs to happen. All right, so what to watch out for when dealing with inequalities? Make sure to reverse the direction of the inequality whenever you multiply or divide both sides of an inequality by a negative number. Also, when it comes to solving an inequality, it is recommended that you always move the variables to the left side of the inequality before solving, as that would make interpreting and graphing the solution set easier. This is not a mandate. It's not as important as the first difference we discussed here. For that, you have to make sure that you follow that. But for this, it is just recommended. As you will see, it will be helpful to interpret the final result when you have the variable on the left side. Let's start by looking at some linear inequalities. Linear inequalities in one variable are just inequalities that can be written in this form. Notice they may not be quite in this form in the beginning, but as long as with some manipulation you can bring them into this form, then it's considered a linear inequality. Now here A and B are both real numbers, and we do not want A to be 0, because then this term would collapse and we would no longer really have a variable inequality of interest, right? So, and it would certainly not be linear anymore, because we would not have a first degree term in the inequality any longer. Where non-zero A and B are real constants, and X is a real variable. Now here the non-zero only applies to A, not to also to B, just in case that was confusing for you. And X is a real variable. Note that greater than may be replaced with any of these other inequality symbols, with greater than or equal to, less than or equal to, and it would still be considered to be a linear inequality. In order for us to be able to present our solutions to inequalities properly, we need to go ahead and review the concept of intervals. All right, first we'll look at finite intervals, and of course by finite we mean the length. As you know, any interval on the number line will have infinitely many numbers in it, right? Just to look at a quick proof of that, take any two numbers a and b. As long as they're different, you can find the number halfway between, right? And then you can find another number halfway between a and that number that you found, and then again halfway between. This process never ends. So there's a quick proof that there are infinitely many numbers in any interval on the number line. So we're talking about only length when we say finite intervals. All right. So the first kind of interval we look at will describe all real numbers between a and b. Now, when you say between two numbers, that excludes the endpoints. These are called the endpoints of the interval. So when you only consider numbers between, you do not include the two endpoints. The way that you can write that in what we call set builder notation is you say all x such that x is between a and b. Given that only real numbers can be compared in this manner using inequality, it's not quite necessary to say all x belonging to the set of real numbers such that this is true. So it's implicitly clear. So when the endpoints are not included, when neither endpoint is included, we consider that to be what's called an open interval. And the way we write that in interval notation is we just use parentheses, a comma b, close parentheses. Now, this is not to be confused with an ordered pair. This is a completely different usage of the same notation we used for an ordered pair. Now, what if I want to include the left endpoint but not the right endpoint? So we say all real numbers between a and b, comma, now we have to say a phrase that's going to tell us the left endpoint should be included, and the way you do that is you say left inclusive. So that means it includes a, but it excludes b. So it's going to look like this as far as the graph is concerned. You fill out the a part, the point representing a, and you leave open the circle representing b, and of course all numbers in between. So because this interval is only open on one side, we call it a half open interval, and this side would be considered closed. And the way we write that in set builder notation is, of course, is all x such that x is greater than or equal to a, but at the same time less than b, right? It's kind of sandwiched between these two endpoints. All right, notice the less than or equal to on the part which you're including, so on the a part, right? Then we have, what if we want to include the right endpoint but not the left endpoint? So we say all real numbers between a and b, right inclusive. So this time you exclude a but you include b. So it's again going to be a half open interval because one part of it is open, one endpoint is open, the other is closed. So we write parentheses a comma b, and then on the part that is included, notice as with the previous part, we always use a bracket. So the part, the endpoint that is included, always use a bracket next to it, whether it's on the left or the right. And the one that is excluded, you use a parenthesis next to it, whether it's on the right or the left. And if both endpoints are included, then we say all real numbers between a and b, and simply say inclusive. You don't say right or left. You don't need to say right and left inclusive. You just say what? You just say inclusive. That means what? Include both endpoints, okay? And of course, both of these are going to turn into less than or equal to. And now we have an interval that's closed on both ends, so we can just call it a closed interval. And of course, we're going to use brackets on both ends. All right, so make sure you know your intervals before we proceed, your finite intervals. Now we'll look at infinite intervals. All right, so infinite intervals, again, we're talking about the length of the interval, right? So what if I want to look at all the numbers that are greater than a given number, right? But not the number itself. So here I say all x such that x is greater than a, right? Notice that's in words, all real numbers greater than a. Now, the way this is going to look is you're going to start, so you basically always have, let's go back to the previous page for a minute. Your interval is always going to look like this. You have either parentheses or bracket, then you put the starting point and then the ending point, right? And then either parentheses or bracket afterward. So start, comma, end, right? Now, when you come to an infinite interval, there is a starting point, like for this one, but there is no ending point on the right side, right? So for that, we use infinity. And of course, infinity is a numerical concept rather than actual fixed number. So we never include infinity. So you will never have a bracket next to infinity. Next to an infinity, whether it's on the right or the left, like this one, for negative infinity, you always use parentheses. So this is the open interval a comma infinity, and it means all numbers greater than a. Now, that is an open interval because notice you have parentheses on both sides. Now, again, here's an interval where we want all numbers greater than or equal to a. So that means we want to include a as well. So for this, we put bracket a comma infinity, like that. Now, if we want all numbers that are less than a given number, like this, all real numbers less than a, we can put it in set builder notation like this, all x such that x is less than a. Now this is an open interval once again because you're going to have parentheses on both sides, and you have negative infinity comma. So where's the starting point? There is no starting point, right? It's going toward negative infinity, so that's why you put negative infinity comma a close parentheses. For half open interval including the endpoint a, so you want all real numbers less than or equal to a, we can write it like this in set builder notation, all x such that x is less than or equal to a, and this is going to be a half open interval from negative infinity to a, and then bracket because we're including the a. All right, so these are your infinite intervals that you need to understand. All right, so finally, let's go ahead and solve an inequality. Remember, it's going to be handled very much similar to an equation, except a couple of things that we've discussed, right? We're always going to change the direction of the inequality if we multiply or divide both sides by a negative number. And we're going to try to always get our variables on the left side of the inequality on our way to solving it. So here we have negative 3x plus 5 greater than negative 7. So notice that we want to isolate the x just like we would if it were an equation, right? So let's go ahead and keep the negative 3x here. And we'll go ahead and move the 5 to the other side. That's going to entail subtracting 5 from both sides, right? Remember, that is not an operation that's going to require any switching of the directions, right? That's the subtraction property of inequality. So we get negative 12, right? So we get negative 3x is greater than negative 12. The 5 and negative 5 cancel out. So now we're going to divide both sides by negative 3, right? And the instant we do that, we have to immediately switch the direction of the inequality. Remember that. Anytime you multiply or divide both sides of an inequality by a negative number, you switch it. Switch the direction. So we get x less than 4. So as far as graphing the solution, now what I recommend with inequalities is always that you graph the solution set before you actually try to write it out. This is all x greater than 4, so you're just going to have 4, a number line with a 4, and then you want open parentheses. So in other words, an open circle because you want all the numbers strictly less than 4, not equal to 4. So it's going to look like that. Now this is really on the number line, but when we're drawing it by hand, we raise it a little bit so it's easier to see. Otherwise, remember, it's these numbers on the number line. This raising is just for ease of viewing, right? So now you can see that the solution set, I'm going to write it in both set builder notation as well as interval notation for us to practice those. So we get all x such that x is less than 4. And remember, what's the starting point here? There is no starting point, so negative infinity, comma, 4. It does end at 4, right? The interval. And then since it's not included, we put parentheses. Just like that, okay? So very simple, very important. All right, let's try this one. Again, if you think you know how to do these, try it on your own before you come and watch and compare your answer to mine. Now, with this, you can see that we're going to want to get the x's on one side and the numbers on the other side. So I said always try to get your variables on the left side, right? So let's go ahead and move the 2x by subtracting 2x from both sides. And let's go ahead and move the 4 to the other side by subtracting 4 from both sides, right? I can actually put it on the 7 if I like. Okay, so now notice we can do both at the same time. So now we end up with what? These cancel out. So you get negative 5x less than or equal to, on this side, these cancel out, so you get 3. Now we're going to divide both sides by negative 5. So I would not just throw a negative 5 under it here. Since we're going to want to change the direction of the inequality right away, I would do it on a new line, right? So I'm going to divide by negative 5. And as soon as I do that, I know that I need to switch the direction. So we end up with x greater than or equal to negative 3/5, okay? So as far as the graph of the solution set is concerned, you're going to draw a number line. You don't need to put a bunch of numbers on there. We're only interested in negative 3/5, right? And this time we want negative 3/5 to be included because it's all real numbers greater than or equal to that. And then there's going to be an arrow to the what? To the right. Those are all the real numbers that are greater than or equal to negative 3/5. So for our solution set, this time we're going to start with a bracket instead of a parentheses because we want negative 3/5 to be included. And then comma, notice there is no stopping point, so this one is going all the way to what? Infinity. And then we go ahead and close with a parentheses. Remember, always parentheses to the right of infinity and to the left of negative infinity. Okay? That's how you do that. Let's take a look at a quick application called the break-even point. That's the production level at which revenue and cost are the same. So basically, you even out, right? You don't make money, you don't lose money. All right, if the revenue and cost of a certain product are given by R equals 4x and C equals 2x plus 1,000, where x is the number of units produced and sold, at which production level, that just means the number of units, right? Does R at least equal C? So that means you want R to be greater than or equal to C. That's the production level you want to find, right? So where do you kind of start to move in toward profitability, right? So you want 4x to be greater than or equal to 2x plus 1,000. We're going to move the 2x to the other side. Remember the trick we had for equations: change sides, change signs. Remember that? So we're going to apply that here. So we're going to move the 2x to the left. So it's going to change signs and it's going to become minus 2x. Of course, you're just subtracting 2x from both sides. But since we do this so often, it's nice to know about this shortcut and use it, but only after you understand it, right? Remember, shortcuts without understanding are just simply asking for trouble, because then you're just memorizing blindly and you're not going to make any progress. But once you really understand something, then it's okay to move into applying some shortcuts. So that should only come with expertise, right? It should not, you don't start any field of understanding with shortcuts. That's problematic, right? That goes against the process of learning and advancing. But you always start with, taking the long way, fully understanding it, and then you will naturally come up with some shortcuts that you can use. All right, so greater than or equal to 1,000. So we get 2x greater than or equal to 1,000. Now we're going to go ahead and divide both sides by 2. Since that's not going to change directions, I can go ahead and take care of it right there. If I'm dividing by a negative, I always go to a new line because I need to change the direction. But if I'm dividing by a positive, I can just show it right there. So I get x greater than or equal to 500. So what is the production level at which R is at least equal to C? Basically 500 units. You always want to answer the question that the problem had asked you with proper units and all, okay? Next, we want to look at what's called three-part inequalities. There are actually two inequalities lumped into one. All right, so when you see this, I want you to understand that you're actually looking at two inequalities that have been lumped into one because of their nature. So on the one hand, you want -2 to be less than 5 plus 3x. And so in other words, logically speaking, this is called a conjunction, right? It's an and statement. And you want 5x plus 3 to be less than 20. Now, the reason we kind of lump them together is because, as you'll see, I'll go ahead and solve them separately here. And you'll see that you would kind of need similar actions in each case, right? So notice we're going to subtract the 5. Let me see. I miswrote this one. It's 5 plus 3x. All right, so we're going to subtract 5 from both sides, right? Notice you have to do the same thing for this inequality, right? So you end up with -7 less than 3x for this one. You end up with 3x less than 15 for this one, right? So here you would go ahead and divide both sides by 3. Notice you would have to do the same thing here, right? So you end up with -7/3 less than x. And of course, there's an and between each pair of inequalities at each step, right? So you get and x is less than 5. So basically, notice you want x to be greater than or -7/3. I'm reading this from right to left, right? If I'm reading this from left to right, I say -7/3 is less than x. If I'm reading it from right to left, it's x greater than. Remember, the inequality sign opens toward the larger number, right? So here the larger number would be x greater than -7/3 or and x less than 5, right? On the number line, it looked like this. You want all the numbers that are greater than -7/3 at the same time less than 5. So it's just these numbers in between, right? All right. So, but we usually don't do this because it's much more efficient just to solve this inequality, three-part inequality, which is, again, two inequalities lumped into one simultaneously. Watch. So here we'll go ahead and subtract the 5. But remember, there are 3 parts, so we have to subtract the 5 from all 3 parts, okay? So we end up with negative 7 less than 3x less than 15. Now we go ahead and divide all three parts by 3. Since we're dividing by a positive number, I'm just going to go ahead and take care of it right there like that. Otherwise, I would go to a new line if I were dividing by a negative number. So I get negative 7/3 less than x less than 5. So of course we get the same result, but notice in a much more efficient and quicker manner. All right, now, of course, the graph is going to be the same. So we can say the solution set in set builder notation is all x such that negative 7/3 is less than x less than 5. How would you read that? You're looking for all real numbers between negative 7/3 and 5, right? That's it. You stop there. You don't say anything like left inclusive, right inclusive, or inclusive. You just say all real numbers between negative 7/3 and 5. That automatically means negative 7/3 and 5 are not included. All right, so this is, of course, an interval notation, parentheses, negative 7/3, comma, 5, and then parentheses again. So that's an open interval for a solution. So what does this mean? That means if you take any number in this region, right, and plug it in, it's going to make this a true statement. Try it. What is the most famous number you know between negative 7/3 and 5? Okay, yeah, that's right. I think I heard you say 0. So try 0. Plug it in. Is negative 2 less than, notice 5 plus 3 times 0 is just 5, right? So is negative 2 less than 5 less than 20? In other words, is 5 a number between negative 2 and 20? Of course it is. So notice, plugging in a number between in this region of the solution set is going to make the original inequality or three-part inequality, compound inequality, true, right? All right, that's what we mean by a solution of an inequality. Notice that equations usually have either one solution, right, or no solution, or infinitely many solutions, right? Remember that? Equations that have only one solution, we call them conditionals. Equations that have no solution, we call them contradictions. And equations that have infinitely many solutions, we call them identities. Remember? Because those are the ones where you end up with something like x plus 1 equals x plus 1. If you solve this, you end up with x minus x equals 1 minus 1, so 0 equals 0. So you get an identity. That means it's always true for every real number. Inequalities are different. With inequalities, sometimes you get no solution, but there is no time that you only get one solution, usually, okay? It's extremely rare that you would get one solution for an inequality problem. So inequalities are usually going to end up giving you intervals of solutions or infinitely many solutions, or sometimes no solution. But there are rare occasions, such as this problem, for example. All right, you're looking for all real numbers whose absolute value is less than or equal to 0, right? Well, notice there's only one real number that's going to satisfy that. So what is it? It would be x equals what? 0, right? So here, for this particular problem, you would have solution set as just having what? One solution. But again, that's a rarity for inequalities. Inequalities either give you infinitely many solutions in the forms of intervals or unions of intervals, or they give you no solution. All right, so next we want to look at some quadratic inequalities. Okay, solving quadratic inequalities is going to involve a little bit of more work compared to solving linear inequalities. So the basic approach is going to be to bring the quadratic inequality into this form. In other words, get all the terms on one side and 0 on the other side, okay? Then you go ahead and try to proceed to factor, okay? This is easy because we're looking for two numbers whose product is negative 12 and whose sum is negative 1, right? So if you think about it, negative 4 and positive 3 are going to do it, right? Notice the product is negative 12 and the sum is negative 1, right? So we have x minus 4 times x plus 3 is less than 0. Okay, so basically what we're going to find are the zeros of this equation, this particular product. So notice that x equals 4 and x equals negative 3. We're going to solve a related equation, which is this equation. And that gives us x minus 4 equals 0, x plus 3 equals 0. So either x equals 4 or x equals negative 3. All right, now we're going to kind of make a table to help us find the solution set. Okay, so here we have a number line and a table. So we're going to use the number line to put our points of interest on it. So we have negative 3 and 4. So what we need to do is we need to find out how this inequality behaves in all three of these regions. The one to the left of negative 3, between negative 3 and 4, and then to the right of 4. So we know what happens at negative 3 and 4. At negative 3 or 4, this product, which is this expression, which is the same as this product, becomes 0, right? So therefore, we'll go ahead and put those in our table too, just out of interest. So the regions of interest are, one is right here, which is negative infinity all the way to negative 3. Then we'll look at negative 3 itself. And then the region right here between negative 3 and 4. Then let's pause and look at what happens at 4. And then the region to the right of 4. So 4 to infinity. Now, we want to know what happens to each of these factors and then, of course, the product. So we can look at the product once we have those results. All right, I'll make this table a little bit larger for our next problem. It'll look better. All right, so now notice that what we're going to do is just pick a sample point from each of these regions. So think of any number between negative infinity and negative 3, meaning any number less than negative 3. Doesn't have to be fancy like negative 4. You don't have to go far, okay? And then pick a number in this region. What's the easiest number to pick between negative 3 and 4? I think I heard you say 0, because that's easy to compute with. And then pick a number to the right of 4, like maybe 5. Like I said, you don't have to go far. All right, now we're going to try these test points. Now, plug in negative 4 into this expression, right? So negative 4 minus 4, that's negative 8. Just put a negative sign here because we're only interested in the sign, okay? Now, plug that into this factor, negative 4 plus 3. That also becomes negative 1, which is negative. Again, we're only interested in the sign. And then at the end, we'll look at the sign of the product. All right, so now we know what happens at negative 3. We know that the product at negative 3 is 0. So we don't need to waste time with plugging in negative 3 because we know what the product is going to be. And remember, we're interested in the product because that's the same as our expression. So at these two, we're just going to put 0. Now, notice that because this is negative and this is negative, the product of a negative and a negative is going to be positive, right? Now we move on to this region. So we're going to plug in our sample point from that region, which is 0. 0 minus 4, that's negative 4, so it's negative. 0 plus 3, that's 3, so it's positive. Now, the product is going to be negative times positive, which is negative, right? Now, at 4, again, we're not going to be wasting time because we know the product is going to be 0 at 4 because this factor becomes 0, so the whole thing becomes 0. Now we're going to pick our sample from 4 to infinity, which is 5. Now, 5 minus 4, that's 1, so it's positive. And 5 plus 3, that's 8, so that's positive. And we know that positive times positive is positive. All right. Now, we're looking for the places where this expression, which is the same as this product, is negative, strictly. So we're not interested in the 0 marks. Those are not going to be included. And we're going to be interested in all the places that we see a negative sign, right? Where the product is negative, so this is the only region. So that's how we know the solution set is going to be the numbers between negative 3 and 4. So you can say it in set builder notation, all x such that negative 3 is less than x is less than 4. Or you can write it as an interval, as the interval from negative 3 to 4. Just like that. Okay? Now, let me ask you quickly, and I'm going to do this test to see if you really understand the process. So let me review first of all. All you do is you completely factor and then make a table with each factor and then put your zeros, the points that make it 0, and then look at all the regions that are created. 2 zeros are going to create 3 regions, right? Do a test point from each region to find out the sign of the product, because every other point is going to behave like the test point in those regions, right? So, and then do the same thing for each region, and then you find your solution. Now, in this case, you were looking for the places where the product is negative. There was only one region, and that was the region between negative 3 and 4, right? So I want you to actually solve this problem now using exactly the same table, because if I gave you this problem instead, you should be able to solve it using exactly the same setup. In other words, you would not need a new table. You would just use the same setup that I have right here, right? Before you do that, let me go ahead and graph the solution set here. The solution set here goes from negative 3 to 4, open circle at each, and then connect, right? Notice here I use this number line just to put where the zeros are so that we can determine our regions. This was not a solution set graph. Remember, this is a prep graph, you know, prepping for our table. All right, so go ahead and pause the video and see if you can solve that, and then come back. Remember, we're ready to write the solution set. You don't have to do any work. I've done all the hard work for you. You should right now immediately be able to tell me what the solution set is. Pause the video, go figure it out. All right, so notice this time we're looking for the places where this product is greater than or equal to 0. So that means either positive, so these two regions, or 0. So those are going to be included. So we're going to go from negative infinity to negative 3. We're going to include all those, but we're also going to include negative 3. So that means parentheses, negative infinity, comma, negative 3, bracket, right? Because we're going to include the negative 3. And here, it's going to be this region, but including the 4, right? Because we want the place where it's also 0. So we're going to have union, bracket, 4, comma, infinity. Okay? So it doesn't matter if the problem had asked you to solve this inequality or any of the other variations with less than or equal to or greater than, etc. It doesn't make any difference. You would have to go through this sign table to get the proper solution if you want to solve this algebraically anyway. So go ahead and make sure that you understand that, and then we proceed. All right, so here's a new one. You should go ahead and pause and see if you can do it on your own, and then come back and compare the answer with mine. Okay, so assuming you did that, welcome back. All right, so now we're going to remember everything is on one side already. Like, for example, you may have seen this problem like this. They may have given it to you as 2x squared plus 5x is greater than or equal to 12. Then you would have first turned it into this. Okay, in other words, the first thing you want to do is get everything on one side and 0 on the other side, right? And now we're going to go ahead and proceed with factoring. One thing that's also helpful is if that lead coefficient is negative, you should multiply both sides by a -1 to turn it into a positive, which would of course reverse the direction. But here we don't have a lead coefficient that's negative, so we don't need to worry about that. All right, so here 2x squared, that's got to be 2x or x, so the only variation is going to come here. Remember, don't use the cross shortcut that we use, or the cross assistive tool that we use, because that only works if the lead coefficient is a 1. Okay, so we can't use it here. Here we're just going to use the trial and error FOIL method. Okay, so what do we think we need here? So what about, again, this you'll become better and better at with time. Since I want a 5, I'm thinking I'm going to get an 8 here, and I'm going to put a 3 here. That should help me out. Notice that the inner product is 3x, the outer product is 8x. What I want is positive 5x, right? That can happen if the 8 is positive and the 3 is what? Is negative, right? So the negative here, positive here. So notice we're going to check it. First times first is first, last times last. -3 times +4 is -12. Inner product is -3x. Outer product is positive 8x, which add up to give me positive 5x. So I know for sure I've factored it correctly. So the associated equality is 2x minus 3 times x plus 4 equals 0. So either 2x minus 3 equals 0 or x plus 4 equals 0, which gives me 2x equals 3 or x equals 3/2, or x equals what? -4. All right, so when I do my table, those are going to be the points of interest. Okay, so basically we know that the two factors of interest are going to be 2x minus 3 and x plus 4, and the zeros of interest are -4 and 3/2. So we're going to be looking at -4, 3/2. So I'm going to leave this here because later I'll turn it into a solution set, but I'm not going to put any dots or anything on it. So just for out of interest, we're going to have this region of interest, -∞ to -4, right? Then we're going to look at -4 itself. We're going to have this region between -4 and 3/2. Then we'll look at 3/2 itself. And then we're going to look at the region to the right of 3/2. So 3/2 to infinity. All right, again, the factors are 2x minus 3 and x plus 4. Okay, so after we're done finding those signs, we're going to determine the sign of the product of 2x minus 3 and x plus 4. Okay, so we'll pick one point out of this region. Again, we can use -5, for example. In this region, once again, that's a negative number, that's a positive, so we know for sure 0 is going to be in there, so we'll just use the easiest number, 0. For this region, from 3/2 to infinity, just pick, that's 1.5, right? So pick 2, 3, whatever. Let's do 3. All right, so now we're going to plug in. So plug in -5 into 2x minus 3. So that's going to be -10 minus 3, that's -13, so negative. I don't care about the value, just the sign, right? Now -5 plus 4, that's going to be -1, so that's negative. So the product of these two factors in this region is going to be negative times negative, which is positive. Now at -4 and 3/2, we know the product is going to be 0. So we don't need to worry about plugging anything in. All right. So in this region, we're going to substitute 0. So 2 times 0 is 0 minus 3 is -3. So that's negative. 0 plus 4, that's positive 4. So that's positive. So the product is negative. Negative times positive is negative. For 3/2, we're done. So 3/2 to infinity, we pick 3. So 2 times 3 is 6 minus 3. That's positive 3. So it's a positive. For x plus 4, we're plugging in 3. 3 plus 4 is 7. So that's positive as well. So the product will be positive as well. This time, we're looking for the places where this expression, which is the same as this product, is either positive or 0, right? So we're interested in this region, right? And this region, right? That's it. So the solution set, we can graph it first. So from -infinity to -4, right? Including -4. So close circle and then arrow to the left. And here we're going to have all numbers greater than or equal to 3/2. So close circle again. And then like that. All right, so we're ready to write it. All right, so our solution set is S equals -infinity to -4 bracket. That takes care of this region, -infinity to -4, including -4. And then union this region. So bracket 3/2 comma infinity, because remember, we want to include the 3/2. That's it. So simple. Remember, it's a little bit more involved, but that's what development and growth is all about, right? You don't want to just be doing the same thing over and over again. Otherwise, your intelligence is going to what? Flatline, right? Your intelligence can grow, but you have to challenge it. You have to always do something new and exciting. You can't just sit there and tell yourself, I'm great, and hope that anything is going to change. If anything, that's going to make us more stupid because we're wasting our time rather than actually developing ourselves. So make sure that you basically invite challenges into your life if you want to become more intelligent. All right. Here's what I want you to do. I want you to take a minute and remember, I've done all the hard work. I want you to solve this problem. I want you to use this, what you see on the board, to solve this problem. All right, so pause the video and see if you can come up with a solution for that. Okay, notice here we're looking for the places where this expression, which is the same as this product, which we have here, is either negative or 0. So the region of interest is going to change, right? That's going to be, here are the zeros, and that's where it's negative. So it's going to be this region, right? So the solution set here is going to change to what? Bracket -4 comma 3/2 bracket. And if you want to do a graph, it's going to be -4, -3/2, closed circle at both endpoints, and then everything in between. All right, so make sure you can handle both of those problems on your own before we proceed. All right, let's go ahead and take a look at a quick application. If a projectile is launched from ground level with an initial velocity of 96 feet per second. Its height s in feet t seconds after launching is given by the following equation: s equals negative 16 t squared plus 96 t, which will look familiar to you if you've taken physics. It uses the gravity of, the acceleration of gravity as well as initial velocity to come up with that. And we want to know, when will the projectile be greater than 80 feet above the ground? Now, this does give you the height, this expression. So we basically want to know when this expression is going to be greater than what? 80. Remember, that's strictly greater than. So we have negative 16 t squared plus 96t, and we want to know when that's going to be greater than 80. All right, let's move everything to one side. So we get that. Now, if you are familiar with numbers enough, you should recognize that these numbers are related. In fact, this is 96 is 6 times 16 and 80 is 5 times 16. So if we divide both sides of this equation by negative 16, we'll hit two birds at once, because we'll also get rid of the negative that's on the lead coefficient as well. However, be super careful. That means we're going to have to change the direction of the inequality. So since I'm dividing by a negative, I'll do so on a new line, negative 16 t squared plus 96t minus 80 divided by negative 16, and then 0 divided by negative 16, and we immediately change the direction of the inequality. So we get t squared 96 over negative, so positive over negative, that's negative, so minus 6t. Negative divided by negative is positive, so plus 5 is less than 0. So we factor that out, looking for two numbers whose product is positive 5 and whose sum is negative 6. Be very careful, because negative 2 and negative 3 is a tempting possibility, but it's not right, because the product would be positive 6. So negative 5 and negative 1 are going to be the ones who are going to take care of this. So t minus 5 times t minus 1 is less than 0. We're going to solve this inequality, but in order to do so, we'll solve the associated equation, which gives us t minus 5 equals 0 by the zero factor property, or t minus 1 equals 0. So either t equals 5 or t equals 1. So when we try to do our table, we're going to look at the numbers 1 and 5. Make sure when you do this little rough sketch, this prep work, that you're putting these in correct positions relative to each other. 5 is greater than 1, so it should be to the right of 1. Okay, now we're going to do our table. All right, so we're looking at factors t minus 5, t minus 1, and then the product t minus 5 times t minus 1. And the regions of interest are, of course, 1 and 5, and then everything to the left of 1, what's between 1 and 5, and everything to the right of 5. So negative infinity to 1, and then we look at 1 itself, and then everything between 1 and 5, and then 5 itself, and then everything to the right of 5. Okay? Now, for this region between negative infinity and 1, the easiest, best number is 0. We'll always take that chance when we can. Use 0. And between 1 and 5, we can just use 2. Between 5 and infinity, we can just use 6, right? So when you plug in 0, 0 minus 5, that's negative 5, so it's negative. 0 minus 1, that's negative 1, so it's negative, and the product of negative and negative is going to be positive. So this product is positive for any number in this region, right? At 1 and 5, we know the product is 0. And between 1 and 5, we're using 2. So 2 minus 5 is negative 3, so that's negative. 2 minus 1, that's positive 1, so it's positive. Negative times positive will give you negative. Now, in this region, we're using 6 as a test point. 6 minus 5, that's 1, so it's positive. 6 minus 1 is 5, that's positive, so the product is positive. Now, because the inequality changed on us, we're looking for the regions where this product is negative. Less than 0 means negative, strictly negative. So these are no good. We don't want the regions where it's 0. We only want this region. So everything between 1 and 5. So basically open circle at 1, open circle at 5, and everything in between. So the solution set, I'm only going to write it in interval notation this time, is just going to be parentheses 1 comma 5. So what does that mean? That means you have to answer the question now, right? That means the projectile is more than 80 feet above the ground between 1 and 5 seconds after it is launched, right? So basically, this is what's going to happen. It's going to be in the form of a parabola, right? So notice at some point after 1 second, it'll reach the height 80, right? Then it's going to be staying above 80 feet in this region, even until even when it comes back, until all the way to gets back to 80, right? So you're finding this region of the path for when it's what? Above 80 feet. All right, so make sure that you can handle that on your own, and then we will proceed. Don't let word problems scare you. As you can see, they just usually not a whole lot to them, and if you just relax, you'll be able to do them. The 3 steps being understand, translate, and what? Solve. Always remember those 3 steps. Understand the problem, go ahead and translate it into math, and then go ahead and solve it. All right. Next, we want to look at rational inequalities. Basically, inequalities that are going to contain at least one rational expression in them. Like, for example, this one, okay? The approach is going to be very similar. Basically, we're going to get everything on one side, and we're going to go ahead and combine terms if we need to, and factor, etc., until we get a simplest form. All right, so let's go ahead and do that. So we're going to go ahead and move that 1 over to the left side, so it becomes this -1. Change sides, change signs. All right, now we need to combine these two. So remember, that's like 1 over 1, right? So the common denominator is x plus 4. So this denominator doesn't need any work, but this other denominator needs to be multiplied by x plus 4. So 5 over x plus 4 minus 1 over 1. You got to multiply this by x plus 4, which of course means you have to do the same on the top, right? So now on the top we have 5 minus quantity x plus 4. Be very careful, you need the parentheses. Downstairs they're both x plus 4s now, so we can just put 1 x plus 4, so like this. All right, so take your time, don't rush. That's 5 minus x minus 4 over x plus 4. You want that to be greater than or equal to 0, right? Now, 5 minus 4, that's 1. So we get 1 minus x over x plus 4. You want that to be greater than or equal to 0. All right, so this time the regions of interest are going to be of 2 varieties. One, the ones that make the numerator 0, that make the fraction basically 0. The other one is as long as, of course, it doesn't make the denominator 0, because if a number makes both the numerator and denominator 0, then the fraction becomes undefined as well. But as long as a number makes the numerator 0 but not the denominator, then it makes the fraction 0. All right, so the other region of interest is going to be where the problem becomes undefined, which is where the denominator is 0. So solve each of those, put 1 minus x equal to 0 and x plus 4 equal to 0. So you get 1 equals x and you get x equals negative 4. So those are going to be our numbers of interest. Again, put this in the proper order. Negative 4 on the left, 1 on the right, right? So let's bring our table back in. All right, this time the terms of, or the factors of interest are 1 minus x and x plus 4. And then we're going to look at 1 minus x over x plus 4, right? Now, the intervals of interest are everything to the left of negative 4, negative 4 itself, everything between negative 4 and 1, and then 1 itself, and everything to the right of 1, so 1 to infinity. Now, in this region, we can just pick, say, negative 5, negative 4. Now, at negative 4, we know it's what makes the denominator 0, so that's where the quotient is undefined. So we'll put U for undefined, okay? 1 is where the fraction becomes 0, because if there's no problem if the numerator of a fraction is 0, as long as the denominator is not 0 as well. 1 only makes the numerator 0. It doesn't make the denominator 0, so 1 does make the fraction what? 0. So this is where the fraction is 0. Between negative 4 and 1, remember, from negative to positive, so 0 is hiding in there somewhere. And then from 1 to infinity, we'll pick 2. All right, now we substitute. Negative 5, 1 minus negative 5. Be super careful here. 1 minus negative 5, that's actually 1 plus 5, which is 6. So this is actually positive. Now, negative 5 plus 4, that's negative 1, so that's negative. Now, what is positive divided by negative? Positive divided by negative, remember, you're looking at a quotient of these two factors. Positive divided by negative is negative, okay? We don't need to worry about that. Now we go here. From negative 4 to 1, we're picking 0. 1 minus 0, that's positive. Be careful, okay? 0 plus 4, that's positive as well. So what is positive divided by positive? Positive. We know this here is going to be 0, the quotient. Now for 2, 1 minus 2, that's negative 1, so that's negative. 2 plus 4, that's 6, so that's positive. What is negative divided by positive? Negative. We're interested in the zones where the quotient is either 0 or positive, right? So this is out, that's out completely, because there it's undefined. So the only zone of interest for us is going to be where? Right there, right? So it's going to be all numbers from negative 4 to 1, right inclusive, right? So don't include the negative 4, because we know it's going to be undefined there. So open circle at negative 4, close circle at 4. And then everything in between, right? Now we can write the solution set. So the solution set is going to be parentheses negative 4, comma 1 bracket, like that. So notice that's basically everything from negative 4 to 1, including 1, excluding negative 4. So there you go. All right, again, similar, but you have that extra thing you need to worry about, which is the denominator being 0, which you don't want to happen because that's where it becomes undefined. So you never include the point at which the denominator becomes undefined in your solution set, okay? And then wherever it's positive. So where is it positive or 0? Right here. All right, make sure you can handle that. We'll move on. All right, let's go ahead and do one more before we call it the day, okay? So you should pause the video, try this on your own. You should know how to do it now, and then come back and compare your answer to mine, okay? All right, so welcome back. This is what I did. We basically are going to move both of those to one side. So 2x minus 1 over 3x plus 4 minus 5 is less than 0. Again, we need a common denominator, so it's going to be 3x plus 4. So 2x minus 1 over 3x plus 4 minus, this is like 5 over 1, so 1 times 3x plus 4 is 3x plus 4. Since we're multiplying the denominator here by 3x plus 4, we got to do the same on the top. We get less than 0. So now we basically have just 3x plus 4 for the common denominator, and we have 2x minus 1 minus 5 times 3x plus 4. Don't forget your parentheses. Is less than 0. So we have 2x minus 1 minus 15x minus 20 over 3x plus 4 is less than 0. So if we go ahead and combine those, we get negative 13x minus, combine the negative 1 and negative 20, so we get minus 21 over 3x plus 4 is less than 0. Okay, so remember there are two things we need to worry about where each of these becomes 0. That because it makes the fraction 0, and this because it makes the denominator 0, which makes the fraction undefined. So set each of those equal to 0. So negative 13x minus 21 equals 0. So that means negative 13x equals 21. So x equals negative 21 over 13. Set the other one equal to 0. 3x plus 4 equals 0. So we get 3x equals negative 4. So x equals negative 4/3. Okay? So the regions of interest are going to be, now you do need to know which one of these is larger, right? So we need to get them to have the same denominator. So let's go ahead and multiply top and bottom of this one by 3 and top and bottom of this one by 13. In order to compare fractions, you got to make sure they have the same denominator. So negative 63 over 39 or negative 52 over 39. Remember, with negative numbers, the larger the absolute value, the actually smaller that it is. So this is actually smaller than this. So negative 21 over 13 will go here, and negative 4/3 will go to its right. All right, so now we can do our table. Okay, so we have negative 13x minus 21, 3x plus 4, and then we want to look at the quotient of negative 13x minus 21 over 3x plus 4. So notice that the regions of interest are going to be everything to the left of negative 21 over 13. So negative infinity to negative 21 over 13. And then negative 21 over 13 itself. And then everything between these two. And then negative 4/3 itself. And then everything to the right of negative 4/3. So negative 4/3 comma infinity. All right, so we need to go ahead and find the sample point here. Let me show you an easy way to deal with that. Go ahead and launch a calculator and just type in negative 21 over 13. Okay, now I think on this calculator, yeah, it'll give you the decimal like that. So notice it's negative 1.6 something. Just go to the left of it. How about negative 2, right? All right, we're going to pick a sample point negative 2. For our other one, so let's put in negative 4/3 as well. Oops, be careful, you don't want that. You just want negative 4 over 3. All right, so something in between those two, so maybe negative 1.5, right? All right, I need to keep this on the top. Let's see, there's a trick for that. All right, so now we know at negative 21 over 13 the fraction is 0, and at negative 4/3 it's undefined, right? Because it makes the denominator 0. All right, so how about negative 4/3 to infinity? That's easy, 0, right? All right, so now we're going to plug in. Now here you're going to be very careful because these can get a little bit nasty. So what we're going to do is we're going to actually use a calculator. So we'll just go negative 13 times, here we're plugging in what? Negative 2, right? For this region. So times negative 2. So exit the parentheses, and then minus 21. That's positive. All right, now we're going to plug in negative 2 in here. I can do that one without a calculator. That's negative 6. 3 times negative 2 is negative 6, plus 4 is negative 2, so that's negative. So the quotient is going to be negative. Positive divided by negative is negative. In here, we're using negative 1.5, right? So watch. If I just double click that, it's going to repeat it. So all I'm going to do is I'm going to just take that negative 2, if I can ever get to it. Okay, there. And I'm going to change it to negative 1.5. And I get negative 1.5, which is negative. So that's all I care about. All right, so let's go ahead and type in the other one too. So 3 times negative 1.5. I think I used, you got to use this negative. Negative 1.5 plus 4. That's negative 4.5 plus 4. It should be negative, right? Right. So negative, and negative divided by negative is positive. Here we're plugging in 0. That should be easy. Negative 13 times 0 is 0 minus 21. That's negative because it's negative 21. And 3 times 0 is 0 plus 4 is 4. So that's positive. Negative divided by positive is negative. Now, notice that we're looking for the places where this quotient is negative. So what are the regions of interest going to be? And it's strictly negative, right? Not or less than or equal to 0. So we don't want even the 0 part, right? And we definitely don't want the undefined part. So the only regions of interest are going to be here and here, right? So we're going to be interested in numbers less than negative 21 over 13. Let's graph it. And also numbers that are greater than negative 4/3. All of those will make our inequality happy. That means what? They'll satisfy it, they'll make it true. So now we're ready to write the solution set. So we want negative infinity to negative 21 over 13, parentheses all around, because we don't want to include negative 21 over 13 because that's where it's 0, and we don't want 0. We want less than 0. Union negative 4/3, comma, infinity. There it is. All right, so I wanted to do this one because it has all kinds of fractions, and I know some of you may still feel a little bit funny about fractions. Don't, because you can see there's nothing different about it. Just the only thing different is you gotta be a little bit more careful, that's all. And that's about it. So that should do it. Make sure that you can do this entirely on your own with no help before you go and start your homework, okay? All right, that should do it for this video, and you take care until the next one.